very nice to see you all. And this is effectively as part of my Head of Department's report. This is the fifth and final time for which I shall do it. So as you may or may not know, I was the first Head of Department to give a talk at the Alumni weekend. My successor has already said that they would do so. I can tell you my successor has not been elected yet, but there's only one candidate. So I've already started telling him or her, I can't tell you which gender they are, about what they might have to do as the academic year unfolds. So one of the delights is to give this talk, then over tea, coffee, or a drink, I take various questions. I'm given some advice by alumni, and you'll see the benefit of that advice. There is something that appears in today's slides that is a result of a very sharp prompt, shall I say, by an alumnus of the department who told me that it was absolutely needed for this to happen in the department. I wanted to apologize as well because we've had problems reaching you because of GDPR, which are none of the departments making the email inviting you to today, and all the events was meant to have been sent out at the beginning of August. It got held up because of GDPR. In the end, because of the rules the university is trying to make sure are being followed, you all got a hard copy, I think, about a week ago, some of you. So apologies. That's one of the reasons why we don't have as many people as we ought to have here. I have one other duty to do, which is not on my slides, which is tell you about the retirements. And I'm also going to tell you about new appointments, because I don't have a slide for new appointments. And I've just checked. I gave slightly wrong information to the OEA committee, the Oxford Engineering Alumni Committee. There's only one person retiring. It's Professor David Limebear, Professor of Control Engineering, who's going back to South Africa. And I'm absolutely delighted, and in fact there'll be a few of you be even more pleased than the majority of you, that we have 3 new academic appointments in this time window from the end of last term to early in the academic year. 1 statutory professor and 2 associate professors are coming in, and they're all women. So I think that deserves a round of applause. And of course, the person who's won the Alumni Prize for the 4th year project is also a woman, so I can really retire from being head of department. I have certainly, I hope, achieved something towards greater diversity in the department. So the women who are coming in, we have a brand new chair in biomaterials. It's Professor Eleanor Stride, who was already an associate professor in the department. She won, again, it's a very tough competition. The top 2 candidates were both women. And we have 2 associate professors in areas that have not really been reached very much by the female species in this department, civil engineering and information engineering. Dr. Perla Maiolino and Dr. Barbara Rossi, who will be joining the department early 2019. So I'm absolutely delighted that it's important. They were the best candidates in each case. It's good in terms of attracting 17, 18-year-olds who are female to come and read engineering. And I'm absolutely delighted to be able to report that in my final report as head of department. You all know that Oxford is still first amongst global universities. You may or may not know. Normally, the rankings are announced the first week of September, so we're able to rejoice in the Alumni weekend, at least the last 2. But this year, they won't be announced until the 26th of September. One of the reasons, I think it's PwC, there's a firm of auditors actually auditing the way the rankings are produced. So it means, and then the subject rankings take about a month after that. So it means that for at least another 6 to 8 weeks, we are the best engineering department in Europe. I think catching up with Stanford would be really difficult, but we weren't that far from Caltech last year. But we're certainly ahead of MIT, our friends in Cambridge up the road, Princeton and Imperial. So, and I'm keen always to mention this to the alumni because myths, I think, have a lifetime of between 3, 4 or 5 decades. So when I came up to read engineering in the late 70s, I was told this was a humanities university. When I started as a university lecturer in 1988, 30 years ago, I was told this was a humanities university and engineering was a poor subject amongst all the arts and humanities. The evidence is we may still be a good arts and humanities university, but we're an overwhelmingly brilliant university in science and engineering. And I hope, as I've said before, that all of you alumni do broadcast that fact as often as you can. So when I started in my talk 4 years ago, which was my first talk, so this is my 5th talk, I presented to you what the department was like. One head department, one part-time deputy head, 85 academics, including 13 statutory professors. And one of the very clear thing that is obvious in this department, and there's some former colleagues of mine here, is the engineering science ethos at the center of the clusters is very strong. So Cambridge has 6 divisions in its engineering department. Imperial has 8 departments within the School of Engineering. Our sister departments here in Oxford, physics has 7 sub-departments, chemistry has 3 sub-departments, but there'd be a revolution in Oxford if an incoming head department tried to break it up into sub-departments. So we very much remain as a unified department with no silos, and actually in many ways it's very helpful not only for the undergrads who come in and are not sure which branch of engineering they're most interested in, but also for some of us, because in my first decade I was in this cluster, late 80s, early 90s, and I was doing VLSI design. In my second decade I moved into neural networks and machine learning, and in my third decade here I set up the Institute of Biomedical Engineering, and I'm fully a card-carrying biomedical engineer. So it was possible to move all through these 3 clusters without any difficulties at all. That is one of the big pluses. But, however, what it does mean is the job of head department is impossible. So if you talk to people like, I see someone who's involved in a FTSE 100 company in front of me. I've talked to Warren East, who used to be the CEO of ARM, is now the CEO of Rolls-Royce. Nobody in industry has more than 12 reports. Here we have a completely flat structure. There are 130 academics now who all report to me, with nobody in between. So it is an impossible job, as you can see. There was no way I could break it up into civil or electrical or mechanical, etc. So we've done it by function. There are 4 associate heads who help me to run the department, one for research, one for teaching, that's the undergraduates, one to look after the graduates, and one to look after the buildings and the space in the department. That's the associate head for infrastructures. The other thing I've tried to do as part of the growth of engineering, and I'll reflect a little bit more on how the department's grown in the last 4 years since I became head of department, we got the green light to increase the number. It took me 18 months and about 6 university committees, at least 3 meetings of each of those university committees, before we got the green light to increase engineering from 160 to 180 per year. So I was able to report last year that we'd actually got close to our targets. On the way to 180, our target was 175. We got to within 1 of our target last year, 2 years ago, 2016. But guess what? The number is down to 167 last year, and it may be 166 this coming year. Is that because we're inefficient? Is that because we don't work hard? No, it isn't. It's because there are 38 colleges out there, 30 of which admit engineering, and they're fiercely independent. And it only takes, look at the difference between 167 and 174. It takes 7 of them to say, well, one of our tutors on sabbatical this year, or he or she has just been awarded this Leverhulme fellowship, so they'll be doing less teaching, so we'll take 1 fewer engineer. And that is one of the challenges of being head of a department in Oxford. You have executive power, you can work your way through the committees and get an agreement to go from 160 to 180. And I said I would say something about expansion. So as you can see from this slide, I've just repeated the numbers from 85 to 130. And I've not asked the university for a single penny to fund this expansion. And in fact, our profit as a department has gone up hugely. Research overheads is the spare money that we can use. When I became head department the year before, it was 4 million, is 9 million in the financial year which just finished. So we're able to fund our own activities from our own success. It's the only way to do it. We're the fastest growing department by a huge amount in university. We funded it mostly from industry, some of it from alumni. We've actually integrated 2 existing research institutes into the department. They came to us. We didn't actually ask them to come and join. They said, look, your model is really working. Can we become part of engineering? That means that I'm effectively now the chief executive of a medium-sized enterprise with an annual income of £60 million. That's roughly 35 million from research and 25 million from teaching undergraduates. We're the 3rd biggest department in university. There are 2 bigger departments, 2 departments in the medical sciences division, but neither teaches undergraduates. So in fact, if you really put the research with a large amount of income, 35 million, together with the fact we teach 170 undergraduates per year over 4 years, we are by far the biggest department in university, and that's why I keep saying the job of head department is impossible. However, it is still enjoyable, and I'm still passionate about engineering at Oxford. What it has meant, this expansion, is now we have critical mass in all parts of the department. So we will have the Jenkins lecture in just over an hour from Professor Byron Byrne. He's just been elected to Royal Academy of Engineering Research Chair. And as a result of that, and other similar elections in civil engineering and further funding from the department or from industry, we've grown civil engineering, which is a traditional form of engineering compared to, say, information engineering. So we now have critical mass in just about every area. I think the only one that's perhaps under threat would be chemical engineering, but all the others are bigger than they were 4 years ago. That allows us to compete better nationally and internationally. So let me just give you some examples. Very prestigious for people like Byron to be elected. These are national competitions. The Royal Academy of Engineering Research Professors. It gives Byron 5 years to do research in civil and offshore engineering, free of all teaching and admin. And it also allows him to appoint a departmental lecturer to support his research group. These are very prestigious. Imperial College have 7 or 8 at the moment. I can't remember. It's either 7 or 8. There were none in this department 4 years ago. There are now 5. That's just to give you the Professor Byron Byrne I've mentioned again. Tim Dennison just arrived from the US. People are coming to the US to be in Oxford. And then Nick Petrinich, Steve Roberts, and Phil Torr are internal promotions, people we backed in their applications to the Royal Academy of Engineering. In 2014, when I stood up, we had one research institute, the Institute of Biomedical Engineering, which is the institute I set up and ran from 2008 to 2012. We now have 5 research institutes in the department. 2 are groups that have expanded. So the Mobile Robotics group has become the Oxford Robotics Institute. OSNI, where our turbo machinery work with Rolls-Royce takes place, is now the Oxford Thermofluids Institute. And 2 of the institutes I mentioned, who've come from outside, been integrated in the department, the Oxford Mann Institute for Quantitative Finance and the Oxford E-Research Centre. And what allows us, as having one CEO and effectively no directors underneath, we're giving semi-autonomy to those research institutes with semi-autonomy of their budgets as well, in order for them to be able to thrive without any form of micromanagement from the department. And I'm just going to very quickly give you some updates, and they're not full updates because of the amount of time that I have, and I want to talk about teaching, but some of the great things that have happened. So, for example, this is the cover of Nature. It's almost unheard of that there's an engineering project on the cover of the Nature journal. This was earlier on, if I remember right, in May. This is the work of Professor Konstantin Kousios about artificial livers, doubling of preservation time. You halve the organs that are discarded. You reduce the post-transplant organ injury. Fantastic work in control engineering, allied with the professor of transplant surgery, Professor Peter Friend, and it's made front page, BBC, etc. But a cover of Nature for a paper is quite extraordinary. This is a report on their randomized controlled trial of this normothermic, normal room temperature preservation of livers. I apologize for this one. I have to be on this one. I don't know if any of you heard me. I think the day before I was on the Today program. You may recognize the person on the right-hand side, Paul Grayson, Lord Grayson. who actually gave the 2002 Lubbock lecture when he was the chief executive of Padoject. Padoject is still the university spin-out. It was spun out of Professor Brian Bellhouse's lab in 1993 originally, and is still the one spin-out in the university which has had the biggest realization financially when it was sold to current vaccines for $900 million back in 2004. Well, Paul Grayson, after a varied career, including being Minister for Science and Innovation in Gordon Brown's government, decided he wanted to go back to being an entrepreneur, came to see me in December 2016, acquired an exclusive license to 4 products for my research lab, and to cut a long story short, but I'm happy to talk to you over a drink. Basically, we floated the company on the stock exchange in August, 17th of August, an IPO. We'd raised 60 million. We didn't take all the money that was offered to us. It was valued at 175 million. And then I looked yesterday, I think it's about 210 million at the moment. But it's really exciting. We are developing a new model to do artificial intelligence on healthcare data. And what is really interesting, in partnership with the NHS. And Paul Grayson has been amazing at getting people in the city to invest into companies that use NHS data. Nobody's done that before. So as I say, over the drinks, I'll be very happy to tell you more about that. It's a really exciting venture. It's what I do when I'm not running the department. So further update in the IBME, Professor Tim Dennison, level of VP in Medtronic, the biggest medtech company in the world, right? We're talking $30 billion, I think was their turnover last year. Biggest medtech company in the world, a VP, comes to take a research chair here in our department. That's the measure of the type of department we are now, funded 10 years by the Royal Academy of Engineering. And in Australia, I've mentioned again, it's fantastic to have another, a third woman as statutory chair in this department in biomaterials. She will be working on the medical campus in Headington on novel biocompatible materials and nanomedicine. So that's one of our research institutes. The Oxford Thermofluid Institute, turbo machinery. Now, I'm going to list a lot of information on the slides that come. I want to finish at my given time of 3:10, so I'm not going to read everything out. You can see it for yourselves. I'm always very willing to do follow-up emails if anybody is particularly interested in any of this, or even to have a copy of any of the slides. But basically, again, this is a great success story in partnership with Rolls-Royce. Doubled the amount of people doing research from 50 to 105, 4 new faculty appointments. It was always, or has been for the last 20 years, the Rolls-Royce University Technology Centre in Heat Transfer and Aerodynamics, but it also has an EPSRC Centre for doctoral training now, the hypersonic flow facility, and that is pretty amazing, as you will see on the next slide. And the excellence in a number of areas, you can see that. And the interesting thing is we used to do a lot of spin-outs in my Institute of Biomedical Engineering when I was there. We did 10 a year, so we did 10 for 10 academics. This is not a place where you'd think there would be spin-outs because most of the work is working Rolls-Royce. We've done 5 since 2012 from that particular centre of excellence. And just to give you some highlights from last year, research into the effects of ice crystals forming and affecting the engine flow. As a result, again, of all this success, attracting big grants, making a difference to industry that we work with, we have been granted planning permission to build an extension to the South Wales building. We've commissioned in hypersonics the fastest wind tunnel in the UK, and that's not a typo. It is 18 kilometers per second, right? So you could try and visualize what that means. And then one of the type of spin-outs in terms of the research that I do, one of the academics there, Professor Ed Walsh, very much expert in fluid mechanics, got interested in microfluids, no boundaries, no silos in the department, and started thinking about how they could be applied to cell biology. In fact, he has a spin-out company. He's been given a year out to spend with his spin-out in this coming academic year. And you can see what happened at this conference in California, Best New Product Award and so on. That's a result of being a fluid mechanics expert, thinking about some of the applications to cell biology and so on, and starting a brand new kind of business area. Oxford Robotics Institute, we've talked many times about the Mobile Robotics Group. And what has happened now, we've said you've been so successful, there are other problems in robotics you're interested in. So for example, dynamic robots, long-lived systems, and our new appointment, Professor Perla Maiolino, tactile robotics. When you're going to haptics with robotics, that's a brand new area that I'll be opening up with the appointment of Perla. So there are now 7 faculty members, 13 postdocs, more than 30 PhD students. And interesting thing, we have our own engineers. These are not researchers, these are not undergraduates, graduates or postdocs, they're engineers. So we're developing the capability because we are developing prototypes, building them, testing them. We have our own teams of engineers, not just in the ORI, but in other places in the department too. Just a few achievements. Again, I don't have time to tell you about all of this. New area of research, a torque-controlled quadruped. So this is a robot that walks, winning a big contract for nuclear energy, going to the Arctic Circle, autonomous Arctic trucks, taking part in the RoboCup, and having autonomous vehicles drive around in Blenheim Palace. E-Research Centre is our kind of opening up to the rest of the university. For example, what they do is they run the Digital Humanities Summer School, where people with arts humanities background come and discuss how digital technologies affect their work and their research. Very successful, unique in Europe. But when we absorb these research institutes, we get them involved in teaching as well. So we have a brand new MSc in Energy Systems, and it's being led by one of the academics from the E-Research Centre. They're getting involved in our second year teaching with a coursework module in scientific computing and high performance computing. Right, so let me go back now to the teaching. I've explained why that number isn't as high as I'd like it to be. But let me tell you about some of the things that we've done just over the last year. I don't know how many of you were here for the tour this morning when we opened up the labs. Again, this is listening to alumni. People said to me, if I come back to the department, I'd love to see what's happened to the Tom building in which I did my undergrad labs. So you can now go and see most of those undergrad labs. And because we are large earners, one of the things I did from the start said we're going to work our way up through the building. Well, it's actually up and down. It hasn't been systematic in terms of the y-axis. But we have basically a 6-year program. We've done 4 years. The 5th year is funded. I'm sure my successor will complete the 6th year to completely revamp all the undergrad teaching labs. So some of the experiments, when I became head of department, some experiments I did as an undergraduate were still there. They've gone, which is fantastic. And it's exactly what you want to happen. We've worked with the undergrads talking about internships with a careers service, and now we expect all our engineers to do at least one summer internship during the 4 years they're in Oxford. And what we're doing as well, we're opening up, due to demand from the undergraduates, to allow them to do summer research internships as well in our research labs. So we're also opening up a program as well as the industrial internship that we strongly advise. We've not made it a requirement, but we expect all of them to do at least one industrial internship during their time here, and we try and help them to find that internship, but also opening the doors of our research labs in addition to do a research internship. You saw the Matt Greenwood Outreach Award, and it's great to have Stanley here to come back and collect it for all the work that he's done in highlighting the department to the new generation. The new EM course is interesting. When I presented 4 years ago my first presentation as head of department, one of the things I had to say, under my predecessor, EM, the decision was made to shut it, and the course will be ending next couple of years as the cohorts cycle through. And that's the one topic about which I had most emails ever. And so we worked very hard, and we set up, as most of you probably know, we just changed the middle E from economics to entrepreneurship, and that's been a fantastic success. And the posts, for the people who teach, we've raised the money either from our own resources or from alumni. And let me come to the final bullet point. Somebody literally grabbed me by the lapels at the end of my first talk, said, where's the 3D printing in the department? And it's completely outside my own area of expertise, but I said, I completely agree with you, there isn't any. There's a bit of activity in some research groups, but there isn't any at all in the undergraduate course. Let me see what I can do. And I'll show you what we've done in a couple of slides. Because what I want to take you through before finishing is briefly an update about EEM, because a lot of you are keen to hear, and then I'll tell you about the 3D printing to finish off with. So EEM, we recruit them in the second year. So we make available to 40 undergraduates a business lab coursework module in the second year after they've done their second year exams when they do their coursework modules. Hugely oversubscribed, and what that means, a lot of them get really turned on to EEM, and we have more people applying for the EEM course than we have places for, and that's great. We want healthy competition. So this 5-day business simulation takes place Worcester College, the Foundry, and Side Business School, and teams of 4 or 5 students. Absolutely fantastic. I mean, I spent a couple of hours there at Worcester College, and the kids were absolutely loving it. I went around asking them, and because actually that particular cohort, apart from my welcome in the first year, I hadn't lectured to them in the first year. The second year, one of the guys turned to me and said, who are you then? So it was great. It meant they could tell me exactly what they thought about it without worrying about the fact that I was actually head of the department. But the level of enthusiasm, and by the way, if any alumni want to come in and sample that kind of thing, come and spend an afternoon with the undergraduates as they do the course. They absolutely love it. Then, if they're selected, they get into the third year. I'm less keen on the slides there than my colleagues gave me. The best research cell efficiency, I think that slide is far too busy, but never mind. We have 2 great academics, Jerome Bergman and Christina Darlin, who teach in the third year. They do engineering management with your own, and also do business and technology strategy, looking both at technology evolution and business strategy. I'm not going to go into the details, but that's just to show you what they actually do. And finally, in their final year, in the 4th year, and by the way, they've done a 3rd-year project, which has second term is on the entrepreneurship and business aspects of it. They have an innovation entrepreneurship course at the business school, because we do this absolutely in partnership with the business school. And one of the issues that I'm having now, some of which I'll probably pass on to my successor, is other departments, math, physics, materials, chemistry, want to come in and say, can we do the entrepreneurship and management? You carry on with your engineers doing engineering, but can we have some of that? And so one of the things that I've got to try and work out is, yes, of course we want to help, but of course we cannot damage our own resource. And then the office that Joe Valentine runs, the faculty office, could be completely overwhelmed if we also got chemists piling in, and materials scientists, and all sorts of subjects. So yes, we want to help, but it has to be done in a controlled fashion. So you've probably been able to see what the 4th year lectures are about. Bring a single project to market. I think this is always very difficult for engineers, and I'm not sure I still agree. I've taken the slides, but actually I'd have a debate with them. I don't think it's necessarily 90% marketing. I think R&D is far more important than just 10%. But anyway, I expect most people in this room would probably agree. But if colleagues give me slides, I don't doctor them. I show you the slides that they've given me. That's what the EEM professors have given me. We have friendly debates about these things. But I like this bullet point. So we mix them with MBA students, and it's really great for engineers, whilst being undergraduates, working with the sort of people they are likely to be working with in industry. And that's another fantastic aspect of this course. 3D printing. So thanks to the alumnus, it was an alumnus, I can't remember who it is. If he's in the audience, come back and we'll share a glass of wine. Basically, raise our own funds. I have invested, as head of department, £500,000 into this. We've bought all the machines. There'll be a picture of shiny machines in the next picture, I think. And we've done the refurbishment of the 4th floor. I don't think we can let you into it because it's still being worked. We've even had to have planning permission, just because we have to vent from one of the machines from the 4th floor in the Tom building. That has added 4 months onto the completion time. But basically, 3D printing, whoever proposed it, you've had a big impact on the department. It's there from the first year. And Stanley, I bet you regret not starting the course now. It's there from the first year when we give them tasters in lectures, but also as part of the mechanical design build and test lab. Second year is in CAD. It'll be in the third year projects. Those who got really enthusiastic and do fourth year projects with 3D printing. So just because that's what he's sent me, we have, I'm going to show you this slide. But basically what you can see, this is the fourth floor. This is the staff and student workshop. Anybody, any alumni here but spent time in that workshop? It's on the fourth floor. So it used to be in the Jenkin at one point. That's where it is now. And the rest of it is basically 3D printing with a big investment in machines. Now, we got a fantastic person, Professor Alfonso Castrillon Peter, to run it. He's an expert on inkjet printing down to the nano level. This is what we can do with the expansion of the department. I went to Alfonso and said, I want you to be the 3D printing champion. No other admin, no other teaching, you do that. And so if you can go to a colleague and say, that's what you're going to do, that's what you're going to be a champion, he's embraced it. He's done a fantastic job. This is going to be a real great addition to the department. And I'm really pleased with where we got to so far. And here's the picture of the machines. There may be experts here. I'm not. But of course, this is all reviewed by the departmental committee before we purchase any machines. But we'll have 18 3D printers and 3D scanners, entry-level machines to let the first years loose on, all the way to research-grade, cutting-edge systems. And I'm sure I could ask people like Paul Buckley, for example, to tell me about the elastomers, the various materials that are being used. I'm not an expert, but I'm told that we cover everything, and printing resolutions down to 15 microns over areas as broad as 900 centimeters squared. So we've really worked. Okay, I report often on what the great research we're doing, but I hope you can also see that we work really hard at improving the teaching. We want to recruit people as well. So I mentioned the outreach program supported by an alumnus of the department. You may have heard about the unique course. 48 came in July, 27 male, 21 female. Head Start, 1 week residential, 20 male, 18 female. We have the open days where Stanley helped large numbers of visitors come through, 2,000 roughly, obviously with their parents these days. So it's of the order of 600, 700 students, prospective students that we see in one academic year in these open days. We don't stay here, we go out as well. And here are some of the activities. We have various regions of the UK that are assigned to us, but we will do Dorset as well. But mostly it's around Birmingham, Walsall, that kind of area. And you can see the type of, at the moment it ranges from years 10, from years 9 to years 13, and the sort of numbers that we reach. This is all done by the people who can do it best. I'm too old to do this kind of event, the outreach. You know, my youngest kid is 26 now, so I'm way past it. Is student ambassadors who can convince the next generations. So Stanley was one of those. We have 30. We have 21 males, and that can't be right. Who's given me? I didn't check that particular slide. The figures have been given there. The percentages can't be right. Anyway, it's 21:9 is the ratio. Should be fairly easy to work out. They're all multiples of 3. Anyway, it's much better than at the moment. Actually, our undergrad course doesn't do too badly. We have 24% female, which is better than national average, which is around 20-21%. But among student ambassadors, the ratio is better than that. Okay, let me just finish with a couple of slides before I hand over to Anna. So, because we've grown research overheads by 120% from about 4 million to 9 million, we can invest in our own future, both in the research institutes and in the teaching. We have a lot more people here to deliver the teaching. We've gone from 1 research institute to 5, also to 5 Roca research chairs, including this year's Jenkins lecture. In the last 4 years, we've done 20 university spin-out companies. In 2017, last full calendar year, there was a headlight on the university website, engineering spins out 1 company a month. We actually did 11, but that's close enough. And the 150th was and Andy Robertson, he's over there, who actually is a senior project manager for Oxford University Innovation. We'll tell you about this. The 150th was a spin out from this department, and it actually span out in San Francisco. That was one of the interesting things about it. 6 degrees from a professor that actually is young enough to have been appointed by me in the department. And so we've gone from 2014, we were 7th, we're now 3rd in the world rankings for engineering. Let's hope we can maintain that position when the new rankings come out, and maybe even nibble at the lead that Caltech has over us. So that's the type of department that we are. I'm happy to supply those slides to anyone who wants to tell people how wonderful Oxford engineering is. And on the teaching side, to finish my last slide, we appointed the first departmental outreach officer funded by an alumnus. We've managed to increase the undergrad numbers, but we're having a rearguard action by the colleges. It's quite hard to meet our target of 180. We will go for 250. That will need action from the top. We've nearly refurbished all the undergrad teaching labs. We're introducing 3D printing throughout the course. We've got an EM course where we raised all the funding to appoint the new professors from alumni. And there was no transition as the 4th years of the old course finished, the 3rd years of the new one started. We have an industrial internship program for undergraduates. We also realized from feedback from students that the way the course is run now, there's quite a distinction between the first 2 years, which are mostly done in colleges, and the last 2 years that are almost uniquely done in the department. And actually our Jenkins lecture this year recognized this and introduced 3rd year tutorials in small groups to facilitate the transition. We already asked kids to come in from school to an Oxford tutorial environment. That's quite a transition. They get to learn tutorial, and then in the 3rd year, that's it. You never have any more teaching in your college. And that was too steep a transition to self-learning and to being entirely in the department. So we introduced small teams. They're organized and given the department, usually, not just from the associate professors. We also train postdocs on to give those, and that's been a great innovation. And what it has meant is that throughout the 4 years, because we have annual feedback surveys, we have increased student satisfaction. So many thanks for coming today for my last overview. Absolutely delighted to have spent 4 years here and to see real results both on the research teaching, and thank you for the support that I've received from alumni. Thank you.